This question asks, rank the following molecules from most acidic to least acidic. So we're going to have the most acidic on the left side and the least acidic on the right side. To answer this question, we have to kind of gauge the molecules that we have. We have 3 carboxylic acids and we have 2 alcohols. So right off the bat, it's really important to know that carboxylic acids are generally more acidic than alcohols. You can just remember that. You can remember pKa values, like carboxylic acids are usually around 5, alcohols are usually around 15-ish. Or you can remember the rules of our acronym CARIO. Just a reminder, C equals charge, A equals atom, R equals resonance, I equals induction, O equals orbital. So let's take a look at our 5 molecules. We've already decided that D and E are going to be less acidic. And the reason why is just going to the idea of the key comparison of alcohols versus carboxylic acids. When you deprotonate a carboxylic acid, you get a molecule that has resonance. Whereas if you deprotonate an alcohol, you get a concentrated negative charge. So it's localized, it can't spread its charge out. So that means that that anion is less stabilized or more reactive. And whenever your anion is not stabilized or more reactive, then it's going to be a better base than it is an acid. So right off the bat, we can kind of narrow some of our choices down. We know D and E need to be towards the end, right? So we'll cross off A and we'll cross off E as our answer choices because they have the carboxylic acids listed as the least acidic. So we've narrowed things down quite a bit already. The next thing to do, so we've kind of used, if we think about CARIO, we've kind of already used the resonance, the R of CARIO to narrow our choices down. The next key CARIO letter that we need is induction. So induction is when you have electronegative atoms, such as fluorine, like we see in this case, that are pulling electron density away inductively through sigma bonds. Right, so we can see that in answer choices A through D. All of them have fluorines attached. Molecule E, which has no fluorines and thus no induction, is going to be the least stabilized of all of our examples. Okay, so E is going to be the least stable, and therefore its acid is going to be the weakest. All right, so let's take a look at the 3 carboxylic acids, A, B, and C. In this case, we have either 2 fluorines like we see in B or 1 fluorine like we see in A and C. And having more than one electronegative atom will increase induction over, say, A and C. So I can say that this is going to be our most acidic molecule because it's going to have the most induction combined with resonance to stabilize the negative charge. So it'll have the most stable base. I'm going to kind of amend what I wrote over here, least stable, and I'm going to write base over here too, just for clarification. So our most stable base will lead to the most acidic acid. Okay, so I can now cross off answer choice D as well, because we know B is the most acidic. Only answer choices B and C are left. So the real question here is, are A and C equal to one another? And the answer to that question is no. They're not equal because the closeness of the inductive atom is important as well. Here, the fluorine is on the alpha carbon, and here it is on the beta carbon. The closer to the anion, the more effect our inductive atom can have. So C is going to be more stable, and thus molecule C will be more acidic than the anion of molecule A. Right? So if you wanted to kind of think about what those conjugate bases look like, you would have this guy and we would have this guy. Okay, and so having the fluorines closer is a stronger inductive effect. So our answer for this question is going to be answer choice C. B is the most acidic, followed by C, and then A. And D is more acidic than E because it has induction, whereas E does not.